Hey everyone, Anthony Sequeira here of the Cisco Learning Network, and this is another video in our series on Multicast, just for our friends at the Cisco Learning Network. We, in this video, are going to go ahead and continue to talk about sparse mode type of multicast environments. And if you remember in the last video, we went ahead and assigned the rendezvous point address to all the systems, but we did it manually. Yeah, we did a static assignment with the IPPIM RP address command, and we had to visit all the routers and educate them manually like that about the existence and the location of the rendezvous point. Yuck. We tend not to like these manual static methods. Wouldn't it be cool if we could have the devices dynamically disseminate that information to all the machines? Well, we can, and there are options for this as we discussed last time. The option that we want to zero in right now on, as you can see, is none other than, dun dun dun, Cisco's proprietary AutoRP for Auto Rendezvous Point. Let's go ahead and take a look at this particular technology. Whoops, let me zoom back in there. All right, here we go. The AutoRP technology is indeed a dynamic method for RP address assignment, but it relies upon multicast for its operation. That's right, the rendezvous point information is going to be disseminated utilizing multicast groups. Oh my goodness. This leads to what Cisco themselves in their documentation call the chicken and the egg paradox. That's right. We need, in order for multicast groups to function in a sparse environment, they need a rendezvous point. Here, the methodology to assign the rendezvous point relies on multicast groups. So you have this chicken and egg type paradox. Unbelievable. What multicast groups, by the way, are utilized in order to make this auto rendezvous point work? Well, you can see that for yourself if you just look at a router. Here is our topology that we've been working with. Remember, we've got the multicast server down in the lower left hanging off R6. We've got a handsome multicast client that wants to receive the multicast traffic up there on R4. We want to make R1 our rendezvous point. What I did, so I wouldn't bore you, is I went into all of these devices and I just got that multicast infrastructure set up. So for instance, here on, let's go to the R1 device. If we look on R1, for example, and I say, show IPPIM neighbor, you can see I went in and set up sparse mode peerings between all these devices. Now, I've done nothing with the rendezvous point, but I have indeed set up the basic infrastructure. All the devices are enabled for multicast. All of the appropriate interfaces are enabled for this sparse mode. Now, if you do a show IPM route on your Cisco equipment, the minute you turn on multicast, they're all going to start participating in this particular group here, 224.01.40. Aha, now we know what this group is that we always see our devices participating in. AutoRP utilizes 224.01.40 and 224.01.39 in its operations. And again, this is kind of silly, right? Because these groups are going to be used to disseminate RP information, but these groups themselves need a rendezvous point in a sparse mode environment in order to function. Our chicken and the egg paradox. So these are the groups that are going to be used by AutoRP. Now, this AutoRP thing needed a fix, obviously, for sparse mode environments, and this is why Cisco invented sparse dense mode. The idea behind sparse dense mode for AutoRP was, okay, for the AutoRP groups that are going to lack a rendezvous point when these machines come online, they will run dense for disseminating the rendezvous point information. And then everything else would run sparse. But here's the problem with sparse dense mode. If you lose your rendezvous point or points, then everything, all of the multicast traffic in your environment will start flooding in that dense mode of operation. So engineers, while excited at first about auto rendezvous point and about sparse dense mode, they quickly became very aggravated with Cisco's solution. Cisco responded by saying, okay, look, run your dense mode everywhere. Run your sparse mode everywhere. That's fine. And we'll give you a command you can initiate on your multicast routers that will fix this issue just for the AutoRP groups. Yeah, it's the IPPIM AutoRP listener command. So the ultimate solution for production environments is to go ahead and utilize sparse mode everywhere, and then go ahead and utilize your IPPIM AutoRP listener command on all of your devices. You don't have to do sparse dense anymore in order to accommodate your AutoRP. Okay, so this is great. By the way, one more option. Yeah, this is kind of interesting. You could go in, of course, and you could statically assign the RP just for the 224.0.139 and 224.0.140 groups. Yeah, you could go in and do static RP assignments for those two particular groups that need it. But that's a little strange, right? You're using a static assignment for these certain groups in your overall multicast infrastructure just to repair the AutoRP situation. I think we all agree. The more sophisticated way in which we're going to operate here is just to go ahead and use that magic command, IPPIM AutoRP listener, on our devices. So speaking of our devices, let's go ahead and let's have some fun. Let's go in and let's go to our topology, and I've already issued the join group command up on R4 to simulate the client, and I've already enabled multicast routing and the sparse mode nature of our multicast infrastructure. So what we're going to do right now is we're going to go in and we are going to enable this AutoRP. We're going to take advantage of AutoRP. And of course, we won't do anything about the IPPIM AutoRP listener, so we'll make sure it doesn't work, right? Okay, let's start up on... Oh, wait a minute, let me back up. There's something else that I need to educate you about here. When it comes to setting up AutoRP, we have two ingredients that are involved. You have what's called the candidate RP that wants to be the rendezvous point. You have a router that's saying, hey, I am wanting to be that RP. Please let me. And then you've got a device that's responsible for telling all the other routers about that. And I call this device the mapping agent. So you've got somebody that wants to tell everyone about this router that wants to be the RP. You can put these two roles on the same machine if you want to, but we'll go ahead and split them up. We'll go ahead and say that R1 wants to be the RP, as we can see in this diagram, and we'll say that R5 wants to be the device that's going to tell everybody about that. Okay, so let's get this started. Let's jump over to the R1 device and let's configure it so that it is the device that wants to be the rendezvous point. How we do this is we say IPPIM, and then, folks, I need some context-sensitive help. And I'll tell you why. The commands for AutoRP are very similar to the commands for something else we're going to look at for dynamically assigning this RP, and that's called BSR, or Bootstrap Router. So the commands between the two technologies are very similar, And also, I struggle with which is the command for the rendezvous point and which is the command for the mapping agent. I always get them confused. So I love the context-sensitive help here. It says, okay, there is a command called RP candidate. No, but that's for BSR. Oh, here we go. Send RP announce and send RP discovery. These are our AutoRP commands. But now again, which does which? I need help. Send RP announce is to send the RP announcement. Send RP discovery is, the RP mapping agent. So on R1, I want this send RP announcement. Gotta love context-sensitive help. I would really struggle to configure this without it. Send RP announce. Okay, then what we do is we say the particular interface that is going to be either acting in this role, or you could just hard code the IP address. But we'll say, okay, the interface that's going to be the RP interface is serial 0/0. Then what we need to do is give it a scope. What's the time to live on this? How many hops is this information valid for? Well, we've got a 1, 2, 3, 4, 5, 6. We'll put in like 8 here, and that'll certainly encompass our entire topology. Okay, we could put in filters. We can put in all kinds of options. We don't need to get into those now. I'll just go ahead and end the command. So R1 is saying to the mapping agent that we're about to configure, hey, I want to be the rendezvous point. I am willing and able to be that RP. All right, now we're going to go over to R5, and on R5, we're going to drop in the appropriate command there for the mapping agent. IPPIM, context-sensitive help, it's send RP discovery in order to configure our mapping agent. Once again, we pick an interface for this particular role. On R5, I'll just pick FA0/0. And then we can go ahead and put in our scope. So there we have it. We've got the mapping agent set up. We've got the R1 that wants to be the rendezvous point. We're ready to go ahead and generate some multicast traffic and test. We're going to go down over to the R6 device where we're going to generate some multicast traffic per our topology, and we're going to see if this ping works. We sure don't want this ping to work, do we? Because we expect the failure here because there is no RP for the AutoRP groups. We've got that chicken and the egg problem here, so this better fail. If it doesn't fail, I'm going to be really nervous. You're going to see me do some frantic troubleshooting. We're going to generate some traffic for the multicast group that I had our subscriber want to join there, 239444, and we're going to source this off of the FA0/0 that's actually running multicast. We ping and we fail. Thank goodness. Now, we have 3 potential fixes. Statically map an RP for those AutoRP groups, or we can go ahead and utilize sparse dense mode, or we can go ahead and utilize that nifty IPPIM AutoRP listener command. I think you know what we're going to do. IPPIM AutoRP listener. It's that easy. I'm going to go ahead and copy that to the clipboard, and we're going to drop it in on every single device in our multicast topology. We're going to go up to R5, and we're going to drop it in. We're going to go up to R1, and we're going to drop it in. And finally, R4. All right, awesome. So now we've kind of repaired the topology so that these AutoRP groups of 224.0.139 and .40 will operate in a dense type of fashion so that the rendezvous point information can be disseminated. But keep in mind, none of our regular multicast groups that we're using for video or gaming traffic or whatever we're doing with our multicasting, none of that will ever run dense mode. That's the beauty of the IPPIM AutoRP listener command. It's got a nice ring to it. IPPIM AutoRP listener. Sorry, way too much coffee today. All right, so let's go ahead and try that ping again. We're at that moment where we're going to go ahead and run the ping again. So let me just pull it back from the clipboard here. Again, generate some multicast traffic to 239.444, sourcing it from fast Ethernet 0/0. This time with our topology repaired, we expect success. And there it is, folks. No problem now. The devices know of their rendezvous point. The AutoRP was able to educate them about that because of our repair. Now, there's a really, really awesome verification command I want to show you right now when you're engaging in this. Obviously, the ping told us it was working. I mean, absolutely told us it was working. But let me show you an awesome, awesome verification command. I wasn't going to show you this, so I hope I remember it. Show IP PIM RP mapping. Yep, there it is. It's a mouthful. Show IP PIM RP mapping. And this command is just awesome. It says, okay, Anthony, the rendezvous point is 10, 10, 10, 1 for your entire multicast scope. And this question mark says, we tried to resolve it via DNS and we couldn't. That's all that means. I've had so many students tell me, what is that question mark all about, Anthony? And I say, just relax. It's not a big deal. And then this is giving us versioning information about the technologies in use here. We got this information from 15.15.15.5. What is that? Why did we get it from that device? That's R5. It's the mapping agent. How cool. So the mapping agent is telling us who the RP is, just as we would have suspected. It says even to us in plain English, hey, this got chosen thanks to the AutoRP. And then it gives us information about how long this has been our RP for these groups and when that information is going to need to be refreshed. So very, very cool, folks. We've got AutoRP functioning right now, and you saw how neat it is. In the next video, I'll go ahead and do BSR, the Bootstrap Router Protocol, because guess what, folks? It doesn't need any fixes. It works great for you right out of the box. So we'll take a look at that one in the next video. I would like to review this, though. Let's definitely review here real quick. Remember, AutoRP, a Cisco proprietary invention in order to get that rendezvous point information dynamically distributed. It uses this concept of a candidate, hey, I want to be the RP, please let me, and a mapping agent, a loudmouth, like me, on the network that tells everyone, hey, everybody, R1 is the mapping agent. The rendezvous point. Yeah, R1's the rendezvous point. Remember, those devices, those roles could be on the same device, but for kind of, for robustness and also for a situation where you might have many, many different rendezvous points, you probably want to separate those roles. Finally, and most importantly, and what drives students crazy is how you got to make the AutoRP work. You got three options. You better use sparse dense mode, which was invented to make it work, or you can use that nifty IPPIM AutoRP listener trick that we used, or, really weird, you could statically assign the rendezvous point just for the AutoRP groups that need it. So there you have it, folks. I sure am glad that you joined me for this video on multicast in our series on multicast here. Remember what we're doing for the CLN. We're coming up with a bunch of multicast videos because, geez, this this content really should have been in the CCNP, in my opinion. So we're kind of filling in the gaps for you on this topic of multicast. Don't expect in the current CCNP here in 2011, don't expect questions on this in your CCNP curriculum, but just understand that, we're just trying to fill in the gaps, as I said. I'll be quiet now. Thanks so much for joining us in this video on none other than AutoRP. We'll see you later coming up for some more videos on multicast that I sure hope you're going to enjoy. Thanks again, everyone.